The main thrust of this topic on rockets is that the thrust is equal to this expression given here. I apologize for that maybe bad pun there, but what I'm trying to say is that that expression you could interpret as a thrust force. So maybe I could have also written it as F sub thrust is equal to this expression. It's written there with absolute values, but I would argue that you might not need to write those as long as you draw pictures and understand that we're looking at a magnitude. I think the reason why the absolute value is there, though, is because if you look at the quantities that are in this expression, V sub E is actually the exhaust velocity for the rocket. So the way rocket engines basically work, right, is they spew out exhaust. But really, when they're spewing out that exhaust has momentum. So if we treat kind of the fuel that is burned and creates the exhaust plus the rocket itself as a closed system and apply momentum conservation to it, that's actually where this expression for the thrust force comes from. And part of that momentum of the exhaust is the velocity or speed that it has, and that's what this V sub E is. It's the exhaust speed or exhaust velocity. There's also this delta M over delta T. That is the rate of mass burn of the fuel. In other words, the rate at which the rocket is burning up fuel as kind of a mass per time, like kilograms per second, maybe. The reason for the absolute value here, though, is because usually the fuel is decreasing in time. So in that sense, this rate could be thought of as being negative. But if you understand that and just make sure that you always put in a positive delta M over delta T, then you don't really need the absolute values. You just need to remember conceptually that that's what you're going to do. Anyway, in this topic, we're going to look at some examples that are going to show us a little bit of how this thrust force comes from an analysis of conservation momentum of the rocket. Some of that stuff, I would say, though, if you don't want to go through lots of kind of formal derivations and such, and we're going to have to probably wave our hands a little bit here and there, because technically to really do it correctly involves calculus, but I'm going to come up with a way of doing it without. But if you want to skip that, feel free to skip through those examples. And then there's a couple examples that involve actually applying this to something. I think one has numbers. The other one is more of a like, what would it look like for a rocket doing this where there's another force there? So those might be more of interest and more relevant.